This is the solution question number 6 from the 2014 Maths Methods paper. 6 part A, we want to determine which of these subsets are subspaces of M2R. 6b, we want to prove that image of T is a subspace of V, and of course this should be part C. We want to find a coordinate vector, the coordinates of this vector with respect to this basis. So for 6 part A, we look at W1. Again, there are no nonlinear terms in here, there are no modulus or numbers, so that gives us a clue that this is a subspace. So it's non-empty because, for example, the vector 1, 2, 0, 1 belongs to W1. So you can see that A plus D is B, 1 plus 1 is 2, and A minus D is C, 1 minus 1 is 0. Now we take general vectors belonging to W1. So here, this vector here belongs to W1 because it's in this form, and this vector is also in W1. You can see it's also in this form. So if we look at alpha u plus v, it gives us a vector in this form, and again you can see that this vector, this element plus this element gives you this, and this element take away this element gives you this. So therefore W1 is a non-empty subspace of M2 over R. Now for W2, you can see here we've got numbers, and that gives you a clue that this is not a subspace. So again we look for a counterexample. So U is the vector 1, 2, 3, 4 does belong to W2 because A plus 1, so 1 plus 1 gives us B, so that's okay. And then C plus 1 should equal D. And here you can see that 3 plus 1 does equal 4. So this vector does belong to W2. However, if you multiply this vector by 2, then we get this matrix 2, 4, 6, 8. Now you can see that this breaks down because we should have the elements in row 1, column 1 plus 1 should give you this element. But 2 plus 1 gives us 3, not 4. So this vector is not in W2. So therefore W2 is not a subspace of M2 over R. Part B is bookwork, so we want to show that image of T is a subspace of V. So I'm not going to go through this. All of this is bookwork, so you can just revise this for the examination. Again, of course, this should be part C, so we want to express this vector in terms of these basis vectors. So we need to find A, B, and C. So we get simultaneous equations for A, B, and C. You can use any method to solve this. I've decided to use row reduction here. So if we apply row reduction, then you can see that we're going to get from here we get C is 7 over 4, and then we can back substitute to find B, and back substitute again to find A. And that concludes the solutions to question number 6.